Welcome back, everyone, to the deep dive. This time, we're going to be looking at how to build software that's, well, secure and can stand up to, all those nasty threats out there.
Definitely a hot topic these days, and for good reason.
For sure. And we've got a great guide for this deep dive. We'll be looking at a chapter from the book, Secure and Resilient Software Development.
A really solid resource.
Yeah, I thought so. So, have you ever thought about, what it actually costs to fix those software problems, security vulnerabilities after a product's already released?
Oh, it can be a nightmare. I mean, the cost can be just astronomical. It's like way, way more efficient to just build security in from the very beginning.
Yeah, so it's not just about, patching things up later.
No, not at all. It's a totally different way of thinking about development.
So it's got to be part of the process from day one, no matter what development methodology you're using.
Right. Absolutely. Waterfall, Agile, XP, doesn't matter. Security has to be baked in from the start. Now, our chapter focuses mainly on custom software, but the principles, they really apply broadly.
Right, makes sense. So let's get down to it. Where does this secure development journey actually begin? What's the first step?
It all starts with understanding the environment your software will live in. Right. You gotta know your organization's security policies, privacy policies, all that stuff.
Of course, yeah. But there's more to it than just internal policies, right?
You also have to think about all those external factors.
You mean all those regulations and industry standards?
Exactly.
Feels like a whole alphabet soup sometimes, IPA, PCI DSS, Sarbanes-Oxley. How do you keep it all straight?
It can definitely be a lot. But those regulations exist for a reason, right? They're there to protect sensitive data and make sure those software systems are reliable.
Yeah, that makes sense. Imagine a healthcare app leaking patient data. Or a financial system that's vulnerable to fraud. Not good.
Not good at all.
Yeah. Okay, I'm seeing how crucial this is. But how do you go from, these general policies and regulations to actually making a secure system? How do you translate all that?
Well, that's where we map those, those high-level requirements to specific security goals. Things like confidentiality, integrity, availability.
Right, right.
You got to define what those actually mean in the context of your software.
So, if I'm building let's say, a messaging app, confidentiality would mean, only the person you're sending the message to can read it.
Exactly.
Yeah.
And integrity means the message isn't messed with, while it's being sent. And then availability means the app's working whenever people need to use it.
Okay, I'm starting to see the connections here, but what about some of those other security goals, non-repudiation and auditing? Those sound a bit more...
A little more complex.
Yeah.
They are important, though, especially in systems where you really need accountability. Non-repudiation means you can prove who did what. So if someone can't deny, sending a message, for example.
Right, makes sense.
And then auditing is all about keeping a record of everything that happens so you can trace it back if there's, an incident or something.
So it's like a digital paper trail.
Exactly. A way to track actions and make sure people are accountable.
Okay, so we've laid the groundwork with gathering those requirements. What happens next? Where do we go from here?
Now we move on to the design phase. This is where it gets fun. We start thinking like the bad guys, Trina, find those weak spots before they even exist in the code.
I like that. It's like a cat and mouse game.
It really is. That's what threat modeling is all about.
So it's about finding the weak spots before someone else does.
You got it. And once we have that map, we use a framework called STRIDE to categorize the different types of threats we might be facing.
STRIDE. Is there a story behind that name?
It's an acronym, actually. It stands for spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege.
Okay, so each letter represents a way someone might try to, mess with our system. Okay, that's a lot to unpack, but I'm intrigued. So tell me more about these STRIDE threats. How do they actually play out in the design process?
Well, let's start with S for spoofing. This is all about impersonation. Imagine, someone creates a fake login page that looks exactly like your bank's website, hoping to trick people into giving away their passwords.
Oh, man, that's scary. I can see how that'd be a huge problem, especially with so many online services these days. So how do you protect against that kind of attack during the design phase?
That's where good design really comes in. You can have multi-factor authentication, right? So it's not just your password. You need, a code from your phone or something.
Makes it way harder for someone to get in, even if they do get their hands on your password.
Exactly. And you also got to think about making it harder for those fake login pages to even exist in the first place, right?
How do you do that?
Strong encryption. digital certificates. Those can help verify that a website is legit and prevent those spooking attacks.
Okay, that makes sense. So we've tackled spoofing. What about T for tampering? What kind of chaos can that cause?
Tampering is all about messing with data without permission. Imagine someone, intercepts a message you send online, and they change what it says before it gets to the other person.
Oh, wow.
Or someone could go into a database and change the data there, maybe to steal money or just to mess things up.
That's pretty unsettling. It's like someone opening your mail, changing stuff, and then resealing it like you never knew.
Yeah, it's a big deal.
So how do you stop that kind of digital tampering from happening?
Encryption is key here. You encrypt the data both when it's being sent and when it's just stored somewhere. Makes it way harder for someone to read it or change it.
So it's like putting a tamper-proof seal on your digital packages.
Exactly. And we don't just stop there. We also think about designing systems that can, detect if there's been any tampering, like an alarm system that goes off if something fishy is going on.
Makes sense. Multiple layers of protection.
Always a good idea.
All right, so spoofing and tampering are down. What about R for repudiation? That one sounds a little more abstract, to be honest.
Repudiation is all about accountability. It's what happens when someone says, nope, wasn't me, and there's no way to prove them wrong.
Like if someone claimed they didn't send an email, even though it totally came from their account.
Exactly. Or, imagine a big system, like controls for a power grid, and an operator messes something up but then denies they did anything.
Yeah, repudiation can have some serious consequences in those situations.
For sure.
So how do you design systems to, prevent that? So someone can't just deny they did something.
You got to have a way to track what's happening. So you'd have, robust logging, auditing mechanisms. That way you have a record of everything that's going on with timestamps and all that.
So it's like a digital security camera recording everything, plus a logbook that says who did what and when.
You got it. That way, if someone tries to deny something, you can just point to the logs and be like, well, actually, the system says you did this at this specific time.
That level of accountability is so important, especially for sensitive systems.
Absolutely.
Okay, on to I for information disclosure. This one feels especially relevant these days with all the data breaches we hear about.
Yeah, information disclosure is a major concern. It's what happens when sensitive information gets into the wrong hands.
So we're talking like customer data, financial records, all that.
All of that. And it can happen in a bunch of different ways.
Yeah, it's not just hackers stealing data, right? It could be accidental leaks or even employees, not handling sensitive information properly.
Right. All of those things have to be considered during the design phase.
So how do you build systems that are actually resistant to this kind of information disclosure?
One of the big principles is least privilege.
What's that?
Basically, it means that you only give people access to the information they absolutely need for their job. If they don't need to see something, they shouldn't be able to.
So it's kind of like security clearances, right? Not everyone has access to all the top secret stuff.
Yeah, good analogy. And then we use techniques like data masking and encryption to protect that sensitive data even further.
What's data masking?
Basically, you're hiding or changing sensitive parts of the data, but you're keeping it usable for what it needs to be used for.
So it's like redacting information in a document. You're hiding the sensitive stuff, but keeping the rest of the meaning intact.
Exactly. And then encryption just scrambles up the data so it's totally unreadable unless you have the key to unlock it.
Yeah.
So even if someone gets in, they can't make sense of the data.
Okay, I like it. Lots of layers of protection. So we've talked about preventing unauthorized access, but what about D for denial of service? Those attacks can be pretty disruptive, right?
Yeah, denial of service, DOS for short, those are all about making a system unusable.
Yeah.
So imagine a website's getting hit with so much traffic that it just crashes. No one can access it.
Oh, yeah, I've definitely experienced that frustration before. It's like trying to squeeze through a doorway with 1,000 other people.
Exactly. And these DOS attacks can be a real problem for businesses that rely on their websites or online services.
So how do you design systems to handle that? How do you build something that can withstand that kind of digital onslaught?
Well, one thing is to use rate limiting. So you limit how many requests someone can send within a certain time frame. That helps prevent them from overloading the system.
So it's like putting a speed limit on the information superhighway to prevent traffic jam.
Exactly. And then you can use load balancers, which basically distribute the traffic across multiple servers so no single server gets overwhelmed.
Like having multiple lanes on that information superhighway.
You got it. And, of course, you also got to have a plan for if things do go wrong.
Mm.
That's where incident response plans come in.
It's like having a fire drill for your software. Everyone knows what to do if the alarm goes off.
Yeah, that's a good way to think about it.
All right, 5 down, 1 to go. E for elevation of privilege. What does that involve?
Elevation of privilege is what happens when someone gets access to things they shouldn't. So, like, imagine a regular user figures out how to get admin privileges.
Yikes, that's bad.
Yeah, they could basically do whatever they wanted at that point.
It's like giving someone the keys to the kingdom.
Exactly. It's a big concern, so we definitely think about it during the design phase.
So how do you design systems to stop someone from, climbing the digital ladder and getting that level of control they shouldn't have?
At least privilege is a big one here, too. You really got to be careful about defining roles and permissions. People should only have access to what they absolutely need to do their job.
So it's a compartmentalizing access, right?
Mhm.
Limiting the damage someone can do if they do manage to get in.
Exactly. And of course, we focus on secure coding practices to try to prevent those vulnerabilities that could be exploited in the first place. We look really closely at the code that handles things like user authentication and authorization.
So you're building a system of checks and balances, making sure no one person has too much power, and every action is carefully scrutinized.
That's a great way to put it. We're always thinking about how to build systems that are secure from the ground up,
Hmm.
making it much harder for someone to exploit weaknesses and get access they shouldn't have.
Okay, so we've gone through all 6 stride categories now. It's clear that threat modeling is crucial during the design phase, but I imagine it's not just a one-time thing, right?
Right. You don't just do it once and forget about it. Threat modeling is an iterative process. So as the design changes, the threat model needs to change too.
So you're constantly adapting your strategy as you learn more about the battlefield.
That's a good way to think about it. And it's not just the development team that's involved. We often bring in security experts too, people who can offer a fresh perspective.
Makes sense. Get those different perspectives to make sure you're not missing anything.
Absolutely. And that actually leads us to another important part of the design phase, design reviews.
Design reviews. So it's not enough to just think about security on your own. You need to get feedback from others.
You got it. Design reviews are where we present our designs to a group of people,
Yeah.
security experts, other developers, architects, and we get their feedback. It's a way to catch potential issues early on.
It's like having a panel of judges scrutinizing your work, looking for any weak spots.
That's a good analogy.
Mhm.
We go through the threat models, explain how we're handling security, and answer any questions they have.
It's about getting that second, third, maybe even fourth opinion to make sure nothing important is being overlooked.
Exactly. And those fresh perspectives can be really valuable. Sometimes the security experts will spot something that the development team didn't even consider.
So it's a collaborative effort.
Absolutely.
These design reviews sound like a crucial part of building secure software, but I imagine they can be pretty time-consuming, especially for big, complex projects.
Yeah, they can be. But the benefits really outweigh the costs. By catching those problems early on, in the design phase, you can avoid having to redo a lot of work later, and you end up with a much more secure system.
Makes sense. Okay, so we've spent a lot of time on the design phase. What's next? What happens after all that designing?
Well, then we move on to the development phase. This is where we actually start writing the code.
Time to bring those designs to life. But even with all that careful planning and threat modeling, I imagine there are still plenty of ways for things to go wrong during coding, right?
You're right. Even with the best intentions, mistakes happen. And even a small mistake in the code can have big security implications.
Yeah, I guess it makes sense. So how do you make sure the code itself is secure? Is it just about trusting the developers to do everything right?
Trust is important, but it's not enough. We need to have systems and processes in place to make sure that security is built into every single line of code.
Okay, so what are some of those systems and processes? What are the tools and techniques you use to make sure the code is high quality and secure?
One of the tools we use is called static analysis.
Static analysis. What's that?
Basically, it's like an automated code review. We have special tools that scan the code, looking for potential security problems, coding errors, things like that.
So it's like having a robot code inspector that can spot those hidden flaws that humans might miss.
Yeah, that's a good way to think about it. And these tools can analyze tons of code super fast, finding issues that would take a human forever to find.
That sounds pretty efficient, but can they really catch everything?
Well, they're great at finding certain kinds of problems, like those Becker overflows you mentioned earlier,
Yeah.
but they can't understand the logic of the code or, the context of how it's being used.
So they might miss those more subtle or logical flaws.
Right.
Okay, that makes sense. It's not a foolproof system. What else do you do besides static analysis?
Well, that's why we also do peer reviews. So developers review each other's code before it gets integrated into the main code base.
So it's about getting a fresh pair of eyes on the code, looking for anything that might have been missed the first time around.
Exactly. Peer review is a really good way to catch those more subtle logic errors or security holes that the automated tools might miss. Plus, it helps to make sure the code is readable and, follows all the coding standards.
It's like having someone proofread an important document before you send it out. You want to catch those typos and grammar mistakes.
That's a good analogy. And it also helps to encourage, collaboration and knowledge sharing among the developers.
So it's a good way to build a culture of quality and security within the team.
For sure.
Sounds like a win-win. But peer reviews can also be pretty time-consuming, can't they? Especially if you're working on a large project.
They can be. But again, the benefits outweigh the costs.
Mm-hmm.
By spending that time on peer review, you're preventing bigger problems later on. And you're building better software.
Right, right. Okay, so we've got static analysis and peer review. Any other techniques you use during the development phase to ensure code quality and security?
Yeah, another crucial one is unit testing.
Unit testing. Remind me what that is again.
So unit testing is about testing those individual pieces of code, like a function or a module. You test them separately to make sure they're working correctly.
It's like testing the individual parts of a car engine before you put the whole thing together.
Exactly. By testing each piece thoroughly, you can catch errors early on before they snowball into bigger problems.
So you're preventing those little bugs from becoming big, nasty problems.
Exactly. And it's especially important for security because even a tiny coding mistake can have huge consequences.
Like what kind of consequences?
Well, a simple error like a buffer overflow that could let an attacker run their own code on the system.
Wow, so they could potentially take over the whole thing.
Yeah, it's a big deal.
That's a stark reminder of how important this stuff is.
Definitely. So we take unit testing very seriously. We write automated tests that cover a wide range of scenarios, including those edge cases and error conditions, just to make sure the code is as robust as possible.
It sounds like you're trying to anticipate what could go wrong and then testing for those scenarios.
Exactly. And by automating those tests, we can run them all the time and catch errors quickly. Saves a lot of time and money in the long run.
So unit testing is a crucial part of building secure software. But what about the vulnerabilities that, slip through the cracks despite all those efforts during design and development?
Well, that's where the testing phase comes in.
The moment of truth. So how do you approach testing with security in mind? Is it just about making sure the software works the way it's supposed to?
Functionality is important, of course, but security testing goes way beyond that. We're really trying to uncover those vulnerabilities that someone could use to, break into the system or steal data. We use a mix of manual and automated techniques to try to find weaknesses.
So it's like having a team of detectives, both human and machine, trying to break into the system and expose those flaws.
That's a good way to think about it. One important technique is penetration testing, or pen testing for short.
Pen testing, okay. What's that?
So we have these skilled security professionals, sometimes called ethical hackers.
Ethical hack?
Yeah, they try to break into the system just like a real attacker would. They use all the same tools and techniques.
So it's a simulated attack.
Right, but it's controlled. It helps us see how well the system can stand up to those real-world threats.
It sounds like a pretty intense job.
It can be, but it's also really important. Those pen testers can help us find and fix vulnerabilities before the bad guys do.
So we've got ethical hackers trying to break in. What other techniques do you use in the testing phase?
We also use automated tools, especially for things like vulnerability scanning.
Vulnerability scanning. I feel like that one's pretty self-explanatory. You just scan for known vulnerabilities, right?
Right. These tools use a database of known vulnerabilities to see if any of them exist in our system.
So it's kind of like a virus scan for your computer, but instead of viruses, you're looking for security holes.
That's a good analogy.
So that's vulnerability scanning. What else?
We also do something called dynamic analysis. That's where we actually run the application and use tools to monitor how it behaves, looking for anything suspicious that might mean there's a problem.
So it's like having a microscope that lets you look at the inner workings of the software to see those hidden flaws that might not be obvious from the outside.
Yeah, that's a great way to put it. Dynamic analysis can catch problems that static analysis and even manual testing might miss, especially the ones that only show up under certain conditions.
Okay, so we've got penetration testing, vulnerability scanning, and dynamic analysis. Is that the whole arsenal? Are there any other security testing tools or techniques?
Those are some of the big ones, but it's a big field. There are tons of other tools and techniques that we might use depending on what we're testing and what kind of threats we're worried about.
It sounds like a constantly evolving field.
It is. New vulnerabilities are discovered all the time, and attackers are always coming up with new tricks. We have to constantly adapt.
So it's a never-ending battle.
In a way, yes, but it's a battle worth fighting. The consequences of a successful attack can be really bad, both for the organization and for the people whose data is at risk.
Yeah, that's a good point. It's about protecting people and their information and maintaining that trust.
Absolutely.
So we've explored design, development, and testing. What happens next? Where do we go from here?
Time to deploy. Time to release the software into the wild and let people start using it.
The moment of truth. But I imagine the work doesn't just stop there. There are still security considerations even after the software's been deployed, right?
Absolutely. Deploying software securely is just as important as beaving it securely.
So you have to make sure it's secure once it's out in the real world, being used by real people.
Exactly.
Yeah.
One key thing is to have a really strong change management process.
Change management, what does that mean?
Basically, it means carefully planning and controlling any changes that are made to the system once it's live, whether it's a software update or a change to the configuration or even a hardware upgrade.
So it's about minimizing the risk of accidentally introducing new vulnerabilities when you're making those changes.
Exactly. We often have a change advisory board, or CAB, to review any proposed changes. They make sure everything's been tested properly and that it won't cause any problems.
So it's like having a team of experts double-checking everything.
Yeah, that's a good way to think about it. And we also have a rollback plan, just in case something does go wrong, so we can quickly revert back to a previous version if we need to.
So it's like an escape hatch.
You got it. We also make sure that the production environment, where the software is running, is as secure as possible.
So you're locking things down, closing any unnecessary ports, disabling services that aren't being used.
Yep, all of that. We also implement really strong authentication and authorization controls so only the right people have access and they can only do the things they're allowed to do.
So you're building a digital fortress with lots of layers of security?
You got it.
Yeah.
And we don't stop there.
Right.
We also have monitoring and logging in place.
Yeah.
So we can keep an eye on what's happening.
So you're watching for any suspicious activity that might indicate an attack.
Exactly. We used various tools to collect and analyze logs, looking for patterns or anything unusual that might mean something's wrong.
So it's like having a security team constantly patrolling the system.
Yeah, that's a good analogy.
Mm-hmm.
And then, if we do detect an attack, we have an incident response plan to guide us.
So it's about being prepared for the worst case scenario and having a plan to, contain the damage and recover quickly.
Exactly.
Okay, so it sounds like you're really thorough when it comes to deploying software securely. You're not leaving anything to chance.
We try our best. Deploying software securely is a complex process, but it's essential if you want to build reliable and secure systems.
Okay, we've covered a lot. From the initial requirements all the way through to deploying the software. Is there anything else we need to think about when it comes to building secure software?
Well, one thing we haven't talked about yet is security training.
Security training. So it's not just about the technology and processes, it's about the people too.
Absolutely. People are often the weakest link in any security system. So it's really important to educate everyone involved in the software development lifecycle about security.
So you need to create a culture where everyone understands how important security is and knows how to make good security decisions.
Exactly. You can have the best security technology in the world, but if people aren't security-minded, they'll find a way to mess things up.
It all comes back to the human element. So how do you actually build that strong security culture? Is it just about training or is there more to it?
Training is a big part of it, for sure. But you also need to make security everyone's responsibility, not just the job of a dedicated security team.
So how do you do that? How do you get everyone on board and make security a top priority?
Well, it starts with leadership. Leaders need to make it clear that security is non-negotiable. And they have to back that up with actions.
So they have to actually invest in the resources and training.
Exactly. They need to support those security initiatives, hold people accountable, and reward good security practices.
So it's about walking the walk, not just talking the talk.
You got it.
It sounds like creating a security culture is an ongoing process, not a one-time thing.
Absolutely. You're constantly reinforcing good habits, celebrating wins, and learning from mistakes.
It's all about continuous improvement.
Exactly.
Okay, I know we've been talking a lot about custom software development, but what about commercial off-the-shelf software? The kind of software that companies buy rather than build themselves. Are the security considerations the same for that?
That's a great question. It's definitely becoming more important as organizations use more and more of the COTS software. A lot of the same principles apply, but there are some unique challenges too.
Like what? What are some of the challenges with securing software you buy rather than build?
Well, one big one is that we usually don't have access to the source code.
Ah, so you can't see what's under the hood.
Right. It makes it a lot harder to find and fix vulnerabilities.
It's like trying to fix a car engine without being able to open it up and see how it works.
That's a good analogy. You're basically trusting that the vendor built secure software.
And that can be a bit scary, right?
Can be. That's why it's really important to do your research and make sure you're buying software from a vendor with a good security track record. You need to understand their development process, how they test for security, all of that.
So you're putting a lot of faith in that vendor.
You are. But even if the vendor is good, you still have to take steps to secure the software once you've installed it.
So what can you do to make that COTS software more secure?
Well, you want to configure it securely. Disable any features or services that you don't need.
To reduce the attack surface.
Exactly. And you definitely want strong authentication and authorization so only the right people can access the software and only do the things they're allowed to do.
So it's about adding those extra layers of protection, even if you can't see the code underneath.
Exactly. And keeping the software up to date is also super important.
So installing those security patches as they come out?
Yep. Those patches often fix vulnerabilities, so it's crucial to install them to protect yourself.
It sounds like securing COTS software takes a lot of effort and vigilance.
It does. But it's crucial, especially since a lot of this software is used for really important business operations. A security breach could be devastating.
That's a good point. Okay, I think we've covered just about everything today. We've gone deep into the world of secure software development, and it's clear that it's not just about writing code, it's about creating a whole culture of security, right?
Absolutely. And it's something that everyone needs to be involved in, developers, security professionals, and users alike.
It's a shared responsibility.
Exactly.
Well, it's been a fascinating deep dive. Thanks for joining us. Until next time, stay curious, stay informed, and stay secure.
Wow. It's amazing how much goes into building secure software. It's really not just about writing clean code. It's a whole different way of thinking, a whole culture of security. You hit the nail on the head. Security has to be woven into every single step of the process, from the very first ideas to, when the software is actually running out there in the world.
Yeah, we've talked about so much today. Threat modeling, secure coding, all those different testing techniques, incident response. It's a lot to keep track of.
It can seem overwhelming, but the trick is to approach it systematically, right?
Yeah.
Break it down into smaller, more manageable pieces. It's like building a house. You wouldn't just start throwing bricks around and hope for the best, right?
Yeah, no, definitely not. You need a plan, a blueprint.
Exactly. You start with a solid foundation and then build up from there, step by step.
So if we're thinking about secure software development like building a house, what would you say the foundation is?
A strong security culture, for sure. That's the bedrock. You need an environment where everyone gets it, understands how important security is, and they feel like they can actually contribute to making things more secure.
So it's not just about having all the right rules and procedures written down somewhere.
No, it goes beyond that. You got to have the right people with the right mindset.
Right, because you could have all the fancy security tools and tech in the world, but if people aren't thinking about security, they'll find a way to mess things up.
Exactly. They might accidentally bypass those controls or make mistakes that could put the whole system at risk.
It's that human element again.
Yep. So how do you actually build that strong security culture?
Yeah.
Well, training's definitely part of it, but it's bigger than that.
Yeah. What else is there?
You need to make security a part of everyone's job, not just the security specialist. It's a shared responsibility.
So how do you get everyone on board with that? How do you make security a top priority for the entire organization?
Well, it really starts at the top with the leadership. They need to make it clear that security is non-negotiable. And they have to show they mean it, not just say it.
Lead by example.
Exactly. Invest in the right resources, the training, and then hold people accountable when things go wrong.
Yeah.
And, reward people for doing things the right way.
Walking the walk, not just talking the talk.
Exactly.
It sounds like, building a security culture It's not a one-time fix. It's something you have to work on constantly.
You got it. It's about constantly reinforcing good habits, celebrating successes, learning from mistakes.
It's a journey.
Definitely a journey. And one that's always changing.
Okay, so we've been talking a lot about custom software, the kind companies build themselves. But what about all that off-the-shelf software, the stuff people buy and use every day? Does the same, security thinking apply there?
That's a really good point, and it's more important than ever because so many organizations depend on this commercial software, the COTS software, to run their businesses. A lot of the same principles do apply, but there are definitely some unique challenges.
Like what? What makes it harder to secure that kind of software?
Well, the big one is you usually don't have access to the source code.
Right, you don't get to see the code behind it.
So you can't just go in and look for vulnerabilities or fix problems directly. You're relying on the vendor to have built secure software.
And hoping they do a good job.
You are. That's why it's so important to really research those vendors and understand their security practices. Look at their development processes, their testing, how they handle vulnerability disclosures.
So you're placing a lot of trust in that vendor's hands.
You are. But even with a trustworthy vendor, you still need to take steps to secure that software once you've got it running.
So what can you do? How do you harden that commercial software and make it tougher for attackers to get into?
One big thing is to configure it properly. Turn off any features or services that you don't actually need. Just like we talked about with custom software, you want to minimize that attack surface. And you also want to make sure you've got those strong authentication and authorization controls in place. So only the right people can access the system and only do the things they're supposed to do.
So it's about adding those extra layers of security, even if you can't see the code itself.
Exactly. And don't forget about keeping the software updated.
Installing those security patches.
Yes. Vendors are always finding and fixing vulnerabilities, so those patches are super important for keeping your systems protected.
So securing off-the-shelf software, it's a mix of doing your homework, setting things up right, and then staying on top of those updates.
It's a process.
And like you said, it's crucial because a lot of this commercial software is running really important stuff.
Absolutely. A security breach could have a huge impact.
Okay, I think we've covered a ton of ground today. It's been a deep dive into the world of secure software development. And it's clear that it's not just a technical thing, it's a responsibility that we all share.
Well said. Developers, security folks, users.
Mm-hmm.
We all have a role to play in making sure the software we build and use is secure and trustworthy.
It's about protecting people, their data, and their trust. Well, thanks for joining us on this deep dive. We hope you learned something new and maybe even feel a little bit more inspired to think about security in everything you do online. Until next time, stay curious, stay informed, and stay secure.